Hello and welcome to Tribe Topper. In this video session, we are going to talk about a couple of problems based on gas laws. So here we have our first problem which says, calculate the percentage change in volume of a fixed mass of an ideal gas when its pressure is increased by a factor of 2 and its temperature increases from 30 degrees Celsius to 120 degrees Celsius. Now, first of all, it's a fixed mass of an ideal gas. You will keep N as constant and we will use the equation which we did in the last session. P1 V1 over T1. That's the equation of state of an ideal gas. PV is equal to nRT. N is 1. R is a constant. So that gives you that P1 V1 over T1. This product is equal to P2 V2 over T2. Now they want us to find the percentage change in volume. So we have to figure out the ratio V2 by V1. So let's take this V1 to this side and bring rest all on the left side, or V2 by V1 is equal to P1 multiplied by T2 over P2 comes down into T1. So rest all four are known to us. The pressure P1 is P. You can write that first in the beginning here, that pressure P1 is P and the new pressure P2 is twice of P because they say it increases by a factor of 2 and the temperature increases from T1 is 30 degrees Celsius. In these questions of solving these problems based on the gas laws, we never use the temperature in degrees Celsius, so please convert it as 273 degrees Celsius plus 30. So you have a temperature of 303 Kelvin and then T2, that's 120 degrees Celsius. So 273 plus 120. So that makes it 393 Kelvin. So these are the temperatures and the pressures. So we are just going to plug in these values. So I'll put it here 2P. Sorry, P1 is P only and P times T2, which is 393 upon 2P times T1, which is 303 Kelvin. Now this will just cancel out P and P. So you have to find out 393 over 2 times 303, which is 606. Solving this you get 0.65, or if you multiply it by 100, because we have to calculate the percentage change, so we'll say there is a 65% change in the volume. Sorry, not the 65% change. There is the new volume. The ratio V2 is by V1 is 65% of that. That means the volume V2 is 65% of V1. So there is a reduction in the volume. How much reduction? 100 minus 65. That gives you 35% of volume has been reduced. Because pressure has been increased, so the volume has been reduced. So the ratio V2 by V1 is equal to 65%, which means V2, the new volume, is 65% of the original volume. So there is a 35% reduction in the volume happened. So now we'll move on to our second problem. So our next problem says two ideal gases are kept at the same temperature in the two containers separated by a valve. As you can see here, we have one container with 6 decimeter cube of volume of a gas and 12 atm pressure, and in the other one there is 3 decimeter cube of volume and 6 atm pressure. Now once you have to figure out here, estimate the pressure when the valve is opened. Then what is going to happen? They are all going to mix up. So let's understand this situation, that before opening the valve you have two initial conditions. So P1 6 decimeter cube and V1 is 6 decimeter cube and P1 is 12 atm and V2 is 3 decimeter cube and P2 is 6 atm. Both of these are, you will say, before opening the valve. Then what is the situation here? The event here is that valve is opened. So what's going to happen after the valve is opened? The total volume V3 is going to be, both the gases will mix up. So what's going to be your total volume? That will be V1 plus V2. So you are going to get a 9 decimeter cube. This is a very obvious situation that once you open the valve, the two gases will mix up. So the total volume has to be 9. And what will be the new pressure? That we have to figure out. So we are going to use the equation which I have told you in the earlier sessions, that P1 V1 is equal to P2 V2. But here we have a different situation that two gases are there before mixing. So we'll say P1 V1 plus P2 V2. That's our initial part. This is equal to P3 V3. And now I have already written everything that is given to you. So this is before opening the valve and this is after opening the valve, right? So we have 6 times 12 plus 3 times 6. Just plug in all the values of P1 V1 and P2 V2 is equal to P3 we have to find out, and V3 is 9. So this is 6 times 12, 72 plus 18, that is 90, is equal to 9 P3. Therefore, what is P3 equal to? That's 90 upon 9, and that gives you 10 atm. So we have simply used the equation. Here the temperature is constant, so that automatically indicates you that the equation that you are supposed to use is P1 V1 is equal to P2 V2. But in this situation, just don't mix it up that P1 V1 V2 is not something different from what we are applying the equation. These two are the initial conditions, so we have to consider them together as something before opening the valve, and then P3 V3 we have to introduce here, which is after opening the valve. So before opening we had P1 V1 plus P2 V2. This has to be equal to after opening, which is P3 V3, and just plug in the values and you find your answer. Right, so now let's move on to our next problem. So our last problem says the Kelvin temperature of a gas is doubled. By what factor does the average speed increase? So sometimes when you read this question, immediately that comes to your mind, how is temperature and speed related? But that you have learned in kinetic theory also. You increase the temperature, the speed of the particle increases. But now by which relation are they related? So we have a relationship which says that kinetic energy is actually a measure of the temperature. So 3 by 2 kBT. So half mv square, that's your kinetic energy, is equal to 3 by 2 kBT. We don't have to worry about any calculations here. So what we see is that your v square is proportional to t. Rest all are constants. Half, mass, 3 by 2, kb, these are all constants. So the relations tells us that v square is proportional to t. So if temperature is doubled, if T is doubled, V square also doubled. But we want what is V. So V square is 2 times the original V. So therefore, what will be V? That will be square root of 2 times the original V. Right? So that means if the temperature is doubled, the velocity increases by a factor of root 2. Right? You can say v square here because the new v square will be 2 times of v square. So root 2 times v will be the new velocity. So that's all in this video session. In the next video session, you are going to learn about the kinetic model of an ideal gas. Thank you for watching.